Okay, so today should be a fairly simple day for you. All right, we are going to talk about definite integration with our UDU substitution, which you know how to do. All right, and then we're also going to talk about how to find the average value of a function. Remember, we have a quiz on Tuesday. Tomorrow we'll do some work on reviewing the past week, and then Tuesday will be our review, and we only have one more thing to talk about before our test. Okay? So we'll have a quiz on Tuesday, and then the block scheduling day for NISA will be our test. On the, I don't know if it's Tuesday or Wednesday of the next week. You're odd, so probably Wednesday. Actually, I have no idea. We'll find out. All right. So we're going to integrate this. I'm going to show you two different ways you can do the UDU substitution when you have limits of integration. All right. So first of all, we're not really going to worry about our limits of integration right now. Let's figure out how to take the derivative of, or the integral of this. Okay. Since we have a function inside of a function, we need to use substitution. What would you like u to be? Which makes du 2x dx. Well, that's nice, right? Because 2x dx is right here, and I'm going to take the integral u to the fifth du. Right now, I am not worrying about my limits of integration. These limits of integration are associated with x, and right now I'm in terms of u. All right? U to the fifth du. Okay? Now, if it was an indefinite integral, we'd need the plus c, correct? But we're actually taking the definite integral. We have limits of integration, so we don't need to worry about our plus c. All right? So, this integral is, because we have limits of integration, right? We have 1/6 x squared plus 1 to the 6th evaluated from 1 to 3. No plus c. All right. So, I think you're going to need a calculator. All right? We need 1/6 times 3 squared plus 1 to the 6th minus 1/6 times 1 squared plus 1 to the 6th. Anybody have something? We have 1/6 times 10 to the 6th minus 1/6 times 2 to the 6th, right?
I think it's 166,656.
166,000.
56.
Exactly?
Yeah.
All right. And do we agree?
No.
Yes.
We have disagreements. Did you just plug in the numbers, or did you do the shortcut in your calculator? Okay.
first part, we didn't subtract the second part.
Okay. Let's just double check on our calculator. Let's get that practice in. Okay. So we're taking the integral of x squared plus 1 to the 5th times 2x with respect to x from 1 to 3. There it is. We were right. Give yourself a pat on the back. Now, we're going to do the same problem. Again. Same problem. We let u be x squared plus 1, which means du was 2x dx. And so we changed this to the integral of u to the 5th du. Right? Now, last time we integrated, changed it back to x, and then evaluated. Correct? Well, you can also, instead of changing it back to x and then plugging in your values, you can change your limits of integration to match u. Okay? So this 1 to 3, that goes with x. X squared plus 1 to the 5th 2x. Alright? Well, let's change them to in terms of u. So if u is x squared plus 1, when x is 1, what does that make u? If x is 3, u becomes 10. So now, we have these limits of integration where when we take the antiderivative, we don't have to change back to x because now our limits of integration are in terms of u. So I can plug into this with u. Okay, so we have 1/6, 10 to the 6, minus 1/6 times 2 to the 6, which is exactly what you plugged in last time, right? Double check.
That's simple.
All right. What? Well, what we did is we took the limits of integration and plugged those in for x. So now our limits of integration are in terms of u. That way when we get here, I can leave it as u. Alright? I do not care which way you do this. Whether you change it back to x and keep your original limits of integration to evaluate, or if you change your limits of integration to use and you evaluate that way. You can decide what you are more comfortable with. Okay? Both ways are fine.
Why is it that sometimes the numbers for the upper and lower limits of integration are to the side of it, and other times they're like on top of it and below it?
It just depends on the equation.
Okay, so it doesn't matter what the whether they're both on top of it.
You mean like here as opposed to here?
Yeah.
Yeah, it's either way.
Is there one on the top and then the other on the side?
Just keep it consistent. Okay. All right. So we have a function inside of a function, correct? We have to use u to u substitution. What would you like u to be? Which makes du Okay. Now we have x squared dx, so we're going to have to divide out that 12, right? So we have 1/12 integral of u to the 4th du. Would you like to change our limits of integration? Yes? Okay. Personal decision. Okay? I'm getting feedback that you want to change the limits of integration, so that's what I'm going to do up here. You want to do it in your notes as the other way? Go for it. If x is 1, what does that make u? If x is 3, what does that make u? $109? Check Megan's work. Yeah? Okay. And what's the antiderivative of u to the 4th? 1/5 u to the 5th. From 5 to 109. So we have 1/60th times 109 to the 5th minus 105 to the 5th. Do you notice what I just did here? I put the 1/60th out in front, and then I put these in parentheses. Is everyone okay with how I wrote that? Just thought it'd be easier for my calculator when I go to plug this in. Well, 109 to the 5th is probably pretty easy.
Okay. 2, 5, 6, 4, 3, 7, 2, 7, 5, 27. Yep.
You divide by 60? Oh, probably. Zach, that's not what you got? We're good? Okay. Your turn. Allison's gonna put her work up here. So Allison changed her limits of integration. Is that 1 to 2?
Yeah.
Okay, from 1 to 2. At least 3 volts.
Oh, yeah.
Okay. Okay. That's okay. I'll just fix these. Alright, here's Allison's work. 0.196 is her answer. Do we agree? No? So, point what? How to do what? Did you put it in as 2/3 instead of 3/2?
Oh, yeah. I have more space on my
Okay. Okay. Alright, so is everyone okay now?
Yeah.
Perfect. Average value of a function. Okay? How do we find an average? Okay, highest minus lowest divided by how many you have. How does this look? Add up our area divided by how far apart we are. Okay. So our average value of a function, okay, average value of a linear function, okay, we can do without calculus, right? But average value of a nonlinear function isn't quite so simple. Here we have this lovely calculus formula to help us, okay? So basically you're going to set up your integral from a to b, and then you just have to multiply by 1 over b minus a.
That's from the average value.
Yep, average value.
So you set up opposite f if b wants f to a certain point.
Right.
Right,
The
right.
integral is this, right?
Right,
I wrote this
Oh.
over here so you could see why
that
it's
is
the average value, okay?
I got
What you need to know is this right here. Whoa, that I tried to circle. The internet has been awful, and so when the connection is bad, this will skip, and that's why that happens. I mean, growing exponentially, and you want to know on average. Okay. You guys find averages all the time, right?
Yeah.
All right. Well, not everything is linear, right? And so this helps us with this function. Hopefully, we can present you with some application problems where you can see this better.
Just hopefully.
I am not thinking of a great example off the top of my head, and I apologize for that. Okay, but the average value helps us in a lot of different aspects, right? But not everything's like this. Here's an example. Okay, so we want the average value of f from 1 to 3. And find the value of x which that observes. Okay. So, here's the homework written. Okay, so 1 over b minus a times the integral from a to b of our function. Notice how I'm putting my function in parentheses because all of it needs to be integrated with respect to x. Okay. So 1 over b minus a is 1/2. Antiderivative of 3x squared. X cubed. Antiderivative of 2x. So we have 1/2 times 3 cubed minus 3 squared minus the quantity 1 cubed minus 1 squared, which is 0, right? So what's 3 cubed minus 3 squared?
27 minus 9, so 18.
Divided by 2? 9. So our average value is 9. Now when we're talking about average value, we're talking about the height of our function, right?
Yeah.
So I want to know, where does this occur?
I'll go back into the algebra.
So 9 equals 3x squared minus 2x. No, you have to set it equal to 0, people.
So reduces. And now you factor it.
Okay, can it be factored?
I'll just. I'm missing one.
Oh, integration.
I don't think you can. That's not even really too bad. I'm pretty sure you can do it.
Not possible? So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you can find it that way. Now, because I have confidence that you all can solve the quadratic, here's your homework.
Thanks. That's pretty good. Still working on it.
What are you working on?
Little physics lesson style.